A very good evening to everyone and welcome to the day 6 of DSA Carnival 2.0. This is Armandas from ADG Item CodeChef Chapter. I will be your host for today's session. Firstly, I'd like to thank Geek4Geeks and Coding Minutes for being our title sponsor and education partners. DSA Carnival is a 10-day bootcamp where we will cover data structure and algorithm from very basic to advanced by top educators from all over India. After the completion of each session, there will be a quiz. The question in the quiz will be based on the topic covered during the session. To attend the quiz, it will be helpful to grasp your knowledge in the topic. Feel free to drop a comment in the live chat if you have any doubt and queries regarding the session. So, the topic for today's session is different sorting techniques. Many of you have encountered sorting techniques as a difficult topic of DSA, but as it is said, it always seems impossible until it's done. And now you don't have to worry about anything more because we have one and only Yash Dwivedi sir with us. Yash Dwivedi, an associate mentor at Geek4Geeks, candidate master at Codeforces, and 5-star at CodeChef. Is a privilege. It is a privilege for me to welcome you, sir. Over to you, sir.
Hi everyone, welcome to the channel. I hope that everyone is doing great. So before we start, I'll give a quick introduction about myself, although someone has given it in a very great manner. So my name is Yash Dwivedi. Currently, I'm working as a mentor at Geeks4Geeks. Besides this, I'm also a candidate master on Codeforces and a 5-star on CodeChef. And I have a teaching experience for more than 1 year now. And I've also been a problem setter for some organizations. So I think so that now we can start. So all of you can just give me a +1 in the chat if my screen is visible perfectly and the voice is also clearly audible so that we can start. Yeah, right. Himanshu is saying DP. Yes, will be covering DP in this particular session only. All right. So a +1 in the chat quickly and make sure to hit the like button as well so that we can start on time. Perfect. So let's start. So let's cover some points of DP. I hope that my screen and everything is perfectly visible. So let's cover some of the points. So before we start, like what is dynamic programming, right? So like do you have basic idea about dynamic programming? Just quickly tell me yes or no. Just wanted to know this thing. You guys have some idea about DP or not? Maybe you might have learned something about it or maybe heard about it. Yes or no? And also comment down in the chat which year you belong to. I just wanted to know quickly that to which year you belong to actually. So take screenshots of the previous state. Little bit okay. Fine, no issues. So at least if you don't know about dynamic programming, so you know about one thing that is nothing but Fibonacci numbers, right? You must be knowing about this thing that is Fibonacci numbers. If I talk about Fibonacci numbers, so I can say that the nth Fibonacci number I have heard. This is a quick introduction about it. All of you can keep on commenting your year in the chat. The nth Fibonacci number is nothing but the sum of the n minus and 1th Fibonacci number plus the sum of the n minus 2th Fibonacci number. Yes or no? Or all of you can quickly tell me that in the chat. Do you agree with me that the nth Fibonacci number is nothing but the sum of the n minus 1th plus the n minus 2th Fibonacci number, right? That is how we calculate for the Fibonacci numbers. Yes or no? Just quickly tell me. Correct. Yes. So we have various ways of writing it. Okay. One of the ways is you can do it iteratively. You can run a loop and then you can say f of I is equal to f of I minus 1. Like let's say if I tell you that okay, f of 0 is equal to 1, and I tell you that okay, f of 1 is equal to, let's say, 1, and I ask you to find the nth Fibonacci number. So for that, what you will do is you will say that okay, let's run a loop. I starts from 2, I is less or equal to n. Then we can do an I plus plus simply. And then what you will do is you will say that Fibonacci of ith Fibonacci number is nothing but I minus 1th Fibonacci number plus the I minus 2th Fibonacci number, right? And then after that, you will observe that nth Fibonacci number will also get calculated like this. So in the end, you will simply return the nth Fibonacci number. That like that how that is how it works actually normally. But if you have to do it, let's say recursively, right? So there is one more way of doing it. The other way that we can think around about this particular problem is, let's say we can do it using recursion as well, right? Many of you must have done it. Just you can write yes in the chat if you must have done it. So what I can do is I can write recursion of int n. Okay, I can write recursion of int n, and let's say this is an integer function which returns with the int. Okay, so what are the base cases in Fibonacci? I can say that if n is equal to 0, or I can say that n is equal to 1. In that case, what would I do? I would simply return 1, because I know that the f of 0 is equal to 1, like f of 0 is equal to 1. Let's say if I say that okay, the 0th Fibonacci number, let's say the Fibonacci number I say that starts like this, something like this, 1 1, let's say 2, like this. And let's say I tell you this thing, that n is the nth Fibonacci number. Okay, and I ask you that okay, you tell me, like, if this is the Fibonacci sequence that I give you, like this, if this is where my Fibonacci sequence starts, like 1 comma 1 comma 2, let's say, if the first number is 1, second number is 1, third number would be 2, fourth number would be 3, fifth number would be 5, sixth number would be 8, then it would be 13, and then 22, and so on. Clear with this? I'm saying that this is my first Fibonacci number, this is second, this is third, this is fourth, this is fifth. So I have to find the nth Fibonacci number. So if I is equal to 1 or 2, in that case, what we can basically say is, we can simply say that okay, in that case we can simply return a 1, because nth Fibonacci number is nothing but 1 here. But if suppose that if we do not do it this way, so what could be the other way of of doing? Like we can say that if n is equal to 2, or n is equal to 1, in that case we'll return a 1. Otherwise what we would return is, otherwise we would simply return nothing but recursion of n minus 1 plus recursion of n minus 2. Okay, otherwise what we will do is, like, let's say if I had to calculate the Fibonacci number, nth Fibonacci number, suppose n was equal to 5. So first of all, what I will say is, I'll call this recursive function to tell me the fourth Fibonacci number, and call this recursive function to tell me about the third Fibonacci number. Yes or no? Many of you must have done it. Do you have idea about this? I hope that you have. Basic recursion, you have idea about this? All of you can write a yes in the chat if you are getting this part. I'm looking at the chats. Okay, Hitansh is saying yes. What about others? What about Heal Life? What about Himanshu? What about other people? Okay, this part is clear, right? Is it clear, or should I make it more clear? Like, for example, what you can say is, for example, let's say if I had to calculate the third Fibonacci number, I'm saying that first Fibonacci number is 1, second Fibonacci number is 1. Okay, I have to, so let's say if I have to calculate the third Fibonacci number. Okay, if I have to calculate the third Fibonacci number, in that case, what would I do? I'll call for the second Fibonacci number, right? As I mentioned earlier here, I mentioned that if I have to calculate the nth Fibonacci number, if n is not equal to 1 or 2, in that case, what I'll do is, I'll simply call the recursive call for n minus 1th Fibonacci number plus the n minus 2th Fibonacci number. I'll get from this recursive call, if this recursive call can give me the nth Fibonacci number, it can also give me the n minus 1th and n minus 2th Fibonacci number, right? So what I will do is, first of all, I'll get the n minus 1th Fibonacci number, then I'll get the n minus 2th Fibonacci number. Once I get them, so I can simply add them up and return. If you suppose I wanted the third Fibonacci number, and so in that case, what I'll do is, I'll call one call for will be for the just immediate Fibonacci number, n minus 1th Fibonacci number. One call will be for the n minus 2th Fibonacci number. Now what will happen is, I'll simply say, in this case, if you observe, so in this case n is equal to 2, and I say that the second Fibonacci number is 2, so you are hitting the base case, that is n is equal to 2, then you return a 1. Okay, so you will, from here you will basically return a 1. And if I talk about recursion of 1, in this case, what happens? In this case, if you will observe again, so what will happen? Recursion of 1, like Fibonacci, first Fibonacci number is also 1, so this function also returns a 1. So this function is returning a 1 and this function is returning a 1, and you have to add them up. So what happens when you add them up? Any idea? This function returns a 1, this function returns a 1. So 1 plus 1 is nothing but 2, and third Fibonacci number is actually 2, because if you observe 1 comma 1 comma 2 is the uh, in this case 1 comma 1 comma 2, this is the third Fibonacci number, correct? This is the third Fibonacci number. Now similarly if you try and observe, so if let's say I write a bigger function, like let's say I say that instead of recursion I'm writing f, in f indicates that I'm calculating the nth Fibonacci number. Okay, so if I have to calculate the sixth Fibonacci number, suppose, so can I say that I'll call for the fifth Fibonacci number, and I'll also call for the fourth Fibonacci number? If I have to calculate the fifth Fibonacci number, so that will be nothing but f of 4 and f of 3. If I have to call for the fourth Fibonacci number, so fourth Fibonacci number will be nothing but the sum of the third Fibonacci number and the second Fibonacci number. Fourth Fibonacci number would be what? It would be nothing but sum of the third Fibonacci number plus the second Fibonacci number. Third Fibonacci number would be what? Sum of the second Fibonacci number plus the first Fibonacci number. Similarly, here also third Fibonacci number would be sum of the second Fibonacci number and the first Fibonacci number. Okay. Now here also this would be f of 2 and f of 1. Everyone is clear with this recursive diagram? Yes or no? Everyone is clear with it? Guys, are you clear with this part? I hope that you are. Okay. You are clear with this part, how this tree is being made? Just quickly let me know in the chat. And if I guess number of people watching are more, likes are less, so you can hit the like button as well and share it amongst your friends as well. Okay. So Sushma is saying yes. Okay, right. So in this case, what will happen? I'll say that okay, this recursive call, you hit the base case, so it returns a 1. Okay, this recursive call also returns a 1. Now for 3, what is the third Fibonacci number? It is nothing but the sum of the second Fibonacci number and the first Fibonacci number. So the third Fibonacci number would be nothing but 2. Okay, so it'll return 2 from it. Then what is the second Fibonacci number? Second Fibonacci number is actually 1. So what is the fourth Fibonacci number? Fourth Fibonacci number is nothing but the sum of the third Fibonacci number and the second Fibonacci number. So sum of the third Fibonacci number is actually 2 and the second Fibonacci number is 1. So I'll say that what is it? It's simply nothing but 3. Okay. Then what will happen? If you observe here, second Fibonacci number is 1 and the first Fibonacci number is 1. So what is the sum? The third Fibonacci number is nothing but the sum of the second Fibonacci number plus the first Fibonacci number. So it would be what? It would be nothing but 2. The sum would be 2. So here from here I'll be returning true, and 2, and from here I'm returning 3. So what is the fifth Fibonacci number? Fifth Fibonacci number is nothing but the sum of the third Fibonacci number plus the sum of the fourth Fibonacci number. So I can say that fifth Fibonacci number is nothing but it is 5. Okay, because if I observe 1 comma 1 comma 2 comma 3 comma 5, so fifth Fibonacci number is nothing but 5. You can observe it. Right now in this case, if you will observe, so I will simply say that okay, my f of 5 is returning me a 5. I went down there, I did some calculations, and I'm getting this part. So my left part is resolved. Let's say if I call for the right. So can I say that I have already calculated f of 4? Yes or no? By doing a lot of effort, I have already calculated f of 4. If you will observe, so I've already calculated this value f of 4. And since I have already calculated this particular value, so should I calculate it again? If you see, I've already calculated f of 4 here, correct? So should I calculate it again? Or if you want to look into a broader picture, so let's move further down. If let's say you move a bit more down, so you will be able to observe here that f of 3 is here, right? F of 3 was here. F of 3 is here, right? A lot of times f of 3 is there. So are you not calculating f of 3 again and again? Is it the requirement? Because every time you see the function is increasing, right? The number of functions are decreasing, increasing. You add 1 function, 2 function, 4 functions. So every time the number of functions are increasing exponentially. Okay, so in this case, the time complexity of your algorithm, of this recursive algorithm, will be order of 2 to the power n, which is very, very high. And how to reduce this? So what we can say is that if we have calculated a particular value, right? Can I say that if you have already calculated f of 4, if you have already calculated f of 4, then why do you want to calculate it again? Why do you want to go so much down and calculate it back again? Yes or no? This will take a lot of time. For each and every number, for each and every nth Fibonacci number that is actually already calculated, if you will calculate them again and again, so it will take a lot of time, it will increase the complexity of your code. So in this particular case, what you can simply do is, you can simply say that you can use the concept of memoization. Okay, you can use the concept of memoization. How? So first of all, what you like up till now, is it clear up till now, guys? Everyone is clear up till now? Yes or no? Everyone is clear up till now? Okay. Hitansh is saying yes. What about others? Okay. Sushma is saying yes. Perfect, perfect. So what do I mean by it? So if you will observe, so f of 4 was already calculated. F of 4 was already calculated here as well. So what will happen if you have already calculated a particular value, so you'll not want to go down again and calculate it back again, because it will increase the complexity of your code. So in this case, what we do is we can use a 1D array, because there is just one dimension, one parameter that's changing, that is n. So we can say that what we can do is, if there are n if you have to calculate the nth Fibonacci number, so you can have a DP or an array, simply a 1D array of size n plus 1. Okay, and what you can do is, initially we can mark all the values as -1. Why -1? Because we will say that, suppose if I have this variable dp of n, so dp of n will denote that, okay, dp of n will denote that how many numbers are there. Okay, dp of n denotes that, okay, this particular Fibonacci number, this particular nth Fibonacci number has been calculated or not. If it is already calculated, then it will not be -1. If it is not calculated, then it will be -1. So let's say if you start your recursion, okay, if you move down here, if you move down here, if you move to this 4, so in this case dp of 4 is what? Actually it is -1. Okay, it is -1. So in that case you will say that, okay, I'll call the recursive calls down and I'll try to calculate it. But once you are coming back up and you are storing this answer that, okay, the fourth Fibonacci number is 3, so you'll simply update your fourth Fibonacci number to nothing but 3. And after you update this to 3, this is the fourth Fibonacci number, right? This is the 0, 1, 2, 3, 4, and 5. So this is the fourth Fibonacci number. So fourth Fibonacci number is calculated as 3. So you'll calculate it and store it. Why? Because next time you want to use it. Now let's say I call for my right subtree. If I call here, so I can see that f of 4 is what? F of 4 is actually already calculated, because it's not equal to -1. In that case, I'll simply return this value that's calculated here. I'll not go down, and this will save a lot of time. Okay, is this part clear to everyone? Everyone is clear with this part? Any doubts in this part, or everyone is clear with this part? You can write clear. If you have any doubts up till now, you can ask me. Any sort of doubt anyone is having? Okay, Hitansh is saying clear. What about others? Others are also clear with it? Okay, perfect. Now in this case, if you will observe here, so let's try and see what actually happens. Now, can I say, like, how many times each and every Fibonacci number is calculated now in this diagram? If you look and see, anyone can tell me. Earlier my complexity of the code was 2 to the power n, but now what is the new time complexity of my code? Anyone? Anyone would like to tell me what is the new complexity if I use the DP approach? If I if I store the values and don't compute them again and again, then how many times I'm calculating? In that case, I'm only calculating order of n times, because I'm calculating each and every Fibonacci number exactly once. From 1 till n, I'm calculating each and every Fibonacci number exactly once. And if I'm calculating each and every Fibonacci number exactly once, so if I'm calling for each and every function exactly once, so that means nothing but order of n, because for every number I'm checking only once, right? So the time complexity of that approach would be order of n. So you can see that how we were having a recursive approach which was very intuitive and which was order of 2 to the power n. We were able to reduce it to order of n time complexity, and the space complexity became order of n as well, because we took the extra array. But you will say that, okay, how does this help? Like, can we have some better example than this? Like, can we have some better, maybe recursive example where we can apply DP? Yes, I will say that. Let's understand the 2D state. You will say that, okay, maybe in 1D it is working fine. Okay, we can see that as well. But suppose that if it was 2D, so I'll say that, suppose a recursive function, okay, you have to suppose a recursive function that is I comma j, okay, and in this recursive function, what you are doing is, one time you are incrementing your I by 1, so you are doing recursive of I plus 1 comma j, okay, and other time what you are doing is, you are calling this recursive call for I comma j plus 1. Okay, clear with this part? What I have made is, I have tried to make a recursive function which has two parameters I and j, and one time what is happening, one time I is getting incremented by 1 and j is passed normally, and the other time what I'm doing is, I'm passing I'm keeping I as the same, and I'm passing my value j as j plus 1. Is it clear? This function is clear, this recursive call type is clear. If I let's say started from 0 comma 0, So I would say that I will be what 1 comma 0 here, and if I go to the other path, so it would be 0 comma 1. Okay, this kind of path. Is this much part clear to everyone? Please tell me, guys. Everyone is clear with this much part? I hope so. Is there anyone who is not comfortable with this part? If you are clear, you can write a clear in the chat. I can still see that the number of people watching us are more than the number of likes. Hitans is saying yes. Okay, Susma is saying yes. Okay, fine. Now what we will be doing is let's try and understand. So suppose you started from 0 comma 0, right? You started a recursive call from 0 comma 0. Okay, so what will happen? You will go to the left. Let's say you go to the left and you call the function, right? You call the function for 1 comma 0. Okay, then you go to the right, you call the function, same function for 0 comma 1. Okay, then you call this particular recursive call for 2 comma 0. You call this particular recursive call for 1 comma 1. You call this call for, let's say, I increase by 1, j remains the same, or you increase your j by 1 and I remains the same. Okay, this call. Then if you observe here, so what I could do is I could have recursion of 3 comma 0, and this would be nothing but recursion of 2 comma 1 because j is changing one time. Then this could be recursion of what? It could be 2 comma 1, or it could be recursion of 1 comma 2. Okay, this could be what? This could be recursion of 2 comma 1, or this could be recursion of 1 comma 2. Okay, similarly here, this could be recursion of 1 comma 2, and this could be recursion of 2 comma 1. Okay, these are the circumstances that I can have. And can I say that there are a lot of states that might be repeating? Yes, if you will observe it. So if you observe clearly, so can I say that here, if you observe f of 1, 1 comma 1 is when I is 1, I is 1 and j is 1, it is calculated here and it is calculated here as well. Let's use some different colors. Let's use some white color. So you can see 2 comma 1 is already calculated here. 2 comma 1, will you calculate it again here? Will you go down and calculate it here again? The tree will go down. I have not drawn it down, but will you calculate it again? No. You can see 2 comma 1 here as well. So will you calculate it again? No, you will not want to do that. No. If you have 1 comma 2 here, if you have calculated it already, will you calculate 1 comma 2 again? Will you calculate 1 comma 2 again? No, you will not do that. Okay, because if you do that, then the overall time complexity of your algorithm will be there are m cross n. Suppose there are m cross n dimensions, right? The maximum that I can go is m, the maximum that j can go is n. So it would be nothing but order of 2 to the power m cross n, which is very, very high, right? It is very, very high. It will be exponential. So for doing this, for optimizing this further, what we can do instead is we can simply say that we can do what? We can simply say that we can store. Now, how many parameters are changing? How many parameters are changing in this particular perspective? Can you tell me? Earlier, when I was calling for Fibonacci, so only one parameter was there, right? Only one parameter n was there. Only one parameter was there. But here, two different parameters are there. That means to store all the states, whether a particular state whether a particular recursive state is already calculated or not, to store it, I actually require what? I actually require 2D grid. Okay, I require a 2D matrix or 2D array. Why? Because what I want to do is I want to store all the states that have been calculated already. Okay, that is one thing. So that is why what I will do is this time around, what I will do, suppose the dimensions are m plus n. So I'll say that I'll declare a DP of m plus 1 size and n plus 1. Okay, because what I want to do is I want to store all the I comma j states that are already calculated. I don't want to calculate them back again. Okay, that's why what I will do is I'll say that, okay, if dp of ij, if a particular cell has already been calculated, right, you don't calculate it again. So for doing this, what we would do is, suppose that if these were the circumstances, like suppose that the case was I had to find the number of unique paths. Suppose actually the question is like this. The question that if I frame the question, so actually the question is number of unique paths that you can get from if you start from the top left corner till the bottom right corner. So what is the number of paths here? Anyone can tell me in this particular grid that I have given you, what is the number of paths? Anyone? Anyone would like to tell me what is the number of paths in this particular grid? Anyone can tell me that? The number of unique paths from the top left corner to the bottom right corner. Can I say that this is one path? Yes. Another path, if I say so, another path could be, let's say, this one, right? This path, right? Another path could be this particular path, Okay, then another path could be this one, like this. Okay, maybe another path could be this one. So there can be a lot of paths, there can be a lot of paths in this particular thing. So what we will do instead is, like, you will observe here, right? Let's say you start from here, let's say you start from here. Okay, if you start from here, if you go here, so from this particular cell, how many paths am I having? I will say that, okay, one of the paths that I can think of is maybe this path, and another path is this path, right? These are the, from this particular cell, for reaching the final index, like if I'm telling you that, okay, you can move only, you can only move in the rightward direction, that is what you can do is, if you are standing at a cell I comma j, so either you can move down means I plus 1 comma j, okay, or you can move to I comma j plus 1, that is you can move towards the right side. If I'm allowing only these two types of movements, so from this cell, from the middle cell, the two different ways of reaching is either you reach like this, okay, or you reach it like this. Okay, these are the two conditions when you can reach it up. So for this, what we can basically do is, we can basically think, and like if you are here, right, so you can see that two paths are there from this particular cell, there are actually two paths existing. But like, how does it help? So you will simply store this thing. Why? Because if you will observe now, if you will observe, so you are saying that, okay, these two paths are existing. But suppose what happens, suppose I start from this particular path, suppose what I do is, I start from here, I go down, then I go towards the right side. So from here, how many different paths I can reach? Like, one of the paths could be this particular path, right? Another path could be this particular path. So do you want to, should you actually iterate through those much paths? No, because if you will observe, if this person, if this particular cell that is there, if it is already saying that from itself, from it, starting from it, there are two paths reaching the end. Okay, so in that case, what will happen? This is one of the paths, correct? This is one of the paths that you can have, actually, because if you see the previously, when this function must have been called, it is storing the value that, okay, from this cell it is having two paths. You can observe here, right? One path is going here, another path is going here. So for that, what you can do is, if you let's say consider this green, if you go down, then you go towards the right side. So actually, one of the paths you will be having like this, and another part would be having like this. But you actually don't have to go till there, okay? Because what you will do is, you will simply say that, suppose from this particular cell you go down and then you go to this side. So you will ask this cell that, how many parts do you have till the end? So this cell tells you 2. So in that case, you will simply return 2 from it. You will not want to go here and here, right? Because it will take a lot of time. And by doing this, by using the memorization approach, your time, a lot of time of yours will be saved. Is this part clear to everyone? Please write clear in the chat, guys, if everyone is clear with this much part. Is it clear? Okay, I hope that this part is clear to everyone. Okay, all right, so this much part is clear, perfect. Now what you have to do is, let's say if you are there, right, so what would you do? So in that case, we can, let's say, have a function. Let's say we had a recursive function. Okay, generally we what have is, we have a recursive function, let's say, in which we have passed the particular grid, we have passed the cell I comma j, and we have passed n comma m. Okay, now what we would do is, here what we will do is, suppose that, what are the circumstances that you will return a 0, that, okay, there is no path existing. So if you fall out of the grid from the left, from the upper side, or if you fall out of the grid from the left side, okay, if I is less than 0, or j is less than 0, or if it happens that I is equal to n, or if it happens that j is equal to m, in all those cases you will simply return 0, because there is no further path possible, right? Otherwise what would you do? Otherwise, you will say that there is one path possible, right? There is one path possible, right? You will say that, okay, answer is equal to 1, right? Answer is equal to 1. That is what you would say. And you will say that, what is the choice one that I can have? Choice one that I can have is that I call the recursive function, I pass the grid, and what I do is I move down in the downward direction. So I plus 1 comma j comma n comma m is what you can pass. And other choice that you could have is, let's say, the choice number 2 that you can have is nothing but, you can start the recursion, you can pass the grid. Okay, you can have the cell I comma j plus 1 comma n comma m. Okay, now what you would do is, you will return what? You would be returning what? So let's say, if this answer I have marked as 0 1, basically, instead of this, what we could have done is, we could have said that, if I is equal to n minus 1, I'm assuming a 0 based indexing, and j is equal to n minus m minus 1 n minus 1. If this is the case, in that case we would simply return 1, indicating that okay, we have reached. So we had two choices. Can I say that I want the sum of two choices? Yes. So I would simply return the sum of the choice 1 plus the choice 2. Okay, that is what we would do. Now in this case, if we will observe, this part is clear, but can I say that I need to do something more? Yes, I need to do something more. Why? Because if I do it like this, can I say that I'll get a time limit time complexity exceeded? Yes, I will exceed the time limit actually here, because I am doing what, the number of computations that I am doing is order of 2, like order of 2 to the power m cross n, which is very very high. So instead of doing that, this what we can do is, what we can do here is, we can apply the DP, we can apply the memoization here. And what we can do is, we just need to do one optimization here, one optimization, just one piece of optimization. So I'll quickly copy this up, or maybe I can erase this up so that we can write it. So what I will say is, I will be having the DP, and I will check that if the DP of ij is not equal to -1, if it is already calculated, then without calculating them again, you directly return the already calculated and stored value. Okay, otherwise if it is not calculated, what is top down approach? Okay, what is top down approach? So I will explain in a minute, like 1 second, let me just write it. So that would be nothing but choice 1 plus choice 2, where suppose that I've written the choice 1 choice 2 over there only, although I've deleted it, but still. Okay, then you will return the DP of ij. What is top down approach? So top down approach is nothing but when you calculate from top higher values, right? When you calculate for higher values, let's say if you were talking about Fibonacci, so what is top down approach? If you wanted to calculate Fibonacci of 4, so you want first of all Fibonacci of 3 and Fibonacci of 2, right? Okay, so this is the top down approach, that first of all you start with the bigger problems, but first of all you go to the smaller problems, you find their solutions up, okay, and then whatever solution they give you, you add them up and return to the parent, so that the smaller like you start from the bigger problems and try to divide them into smaller problems of the similar nature. And after you have divided them, so what happens, they will basically compute themselves through the help of the base condition. And after they have computed themselves, after that what they will do is, you will simply get the final answer. Is this part clear? So Sushma, is this part clear to you? I hope that this part is clear. Is it clear to you, Sushma? Hitansh is saying got it. Okay, fine, great. So in this case, if you will observe, right, so the time complexity would be what? You can tell me in this grid the time complexity will reduce to what? It will reduce to what? Can you tell me, Sushma? Can you tell me, Naman, let's say? Can you guys tell me what would be the new complexity? It would be nothing but order of n cross m, because I'm visiting each cell exactly once. That is how I'm optimizing it. But in this case, the space complexity will also be order of n cross n. Okay, that would be the time complexity. This would be the space complexity. Now, similar things you can use in concepts, right? Like you will find a lot of problems. Like this was about the memoization concept. But what kind of problems you can find? So there are many kind of problems. Like how many of you have heard about this problem? Let's see how many of you have heard it. Best time to buy and sell stocks, right? Has anyone heard about this particular problem? Anyone has heard about this kind of a problem? Yes or no? I think so that you must have had heard about it. Correct? Many of you must have heard about this thing. Yes, it is present on many websites. So it has a part, like it has many parts, right? It is of medium level, hard level, many types of levels. But using, first of all, you can solve this problem using recursion, okay? And then once you solve it using recursion, so you can basically memorize this kind of problem as well. Okay. Apart from this, many of you must have heard about the knapsack problem, right? Okay, that is nothing but take, not take. This problem also can be done using this approach. Then there are various other variations, like you can say the longest increasing subsequence, LIS, LCS. Okay, LPS also, longest palindromic sequence. Okay, this kind of things are also there. Then apart from this, it is also applied, DPs is also applied in the concept of matrix chain multiplication, you can say. And apart from this, there are some various other applications, like DP also has the bit mask DP. You also apply the bitmask DP for optimizing a lot of problems for not calculating some states again and again. And apart from this, you also have the digit DP. So these are various types of dynamic programming that you can have. But let's understand with the help of the buy and sell stock. Okay, so let's say if I ask you that what you can do is you can do one transaction. Okay, suppose like although in the problem, if I make the problem hard, then it can do 100 transaction, 200 transaction. But suppose I ask someone that okay, you can do one transaction, right? You can do one transaction. Like one transaction means one buying. Okay, one time you can buy, and one selling is what you can do, right? So if I ask someone that okay, the maximum number of like you can do in one, you can only do one transaction, that is you can do one time selling, one time buying, and one time selling. So how will you get the maximum profit? Okay, if I ask someone this question, so what can you do for this? So for doing this also you can have the recursive approach. Okay, so what are these? You need to be very good with the making of the choice diagrams. Like let's say if I start, okay, if I'm currently at a particular index I, okay, if I'm currently at a particular index I, so suppose that I have not bought, right? Suppose that I have not bought any particular stock, right? If up till now I've not bought any particular stock, so if I've not bought any particular stock, in that case I can say that I will have two choices, that either to move to the index I plus 1, okay, and do not buy, okay, do not buy. Or what I can say is, I can also say that I move to the index I plus 1, okay, I move to the next index, but I buy the stock, okay. If I will buy the stock, then if I'm buying it, right, if I'm selling it, then I will be booking a profit of array of I. But if when I, this is when I sell, this is when I sell, so that will be plus array of I if I sell it. But if I am buying it, so in according to me, the impact that it will create on me is nothing but minus of array of I. How many of are clear with this? If suppose that if I buy the ith stock, then my account would decrease by minus of array of I. But if I sell the ith stock, then what will happen? If I sell the ith stock, then my amount would increase by array of I. Yes or no, guys? All of you can tell me in the chat. Yes or no? I'm just waiting for your responses. Fine. Okay. Okay. These are the two choices that you can have. Let's draw the other choice diagram. Okay. Suppose you have bought, right? So suppose your bought is equal to true. So you are currently holding a particular cell, right? If you are holding a particular cell, then what will happen? Suppose I ask you that okay, in 100 transactions, right, you have to do what? You have to maximize your profit, okay, or maybe something or the other. So what I can say is, if you have currently bought a cell, right, and you are now at a particular ith cell, so either you can say that you can book a profit of array of I at this particular cell by selling, okay, by selling the ith good, like by selling the commodity at the ith price, and then you can book this much profit, correct, and you can move to the next index. Other thing that you can do is, from here, the other thing that you can do is, you can choose not to sell, okay, you can choose not to sell. And what you, in that case, what will happen if you choose not to sell? In that case, simply you can say that you will move to the next index, and currently your bought will be equal to true only because you have bought and you have not sold up till now. Okay, so can I say that when you sell, okay, in that case what happens? One transaction gets completed when you sell. So when one transaction gets completed, then you will decrease the number of transactions by one. This is also one thing. Let me just have a look if we have a problem on GFG. I think we have, like, best time to buy and sell stocks. Let's quickly consider this problem up. uh, GFG practice, if I write like this. Okay, so we have this particular problem, stock buying and selling. Okay, let's quickly check this out. So if we have a closer look at this problem, so this problem says that the cost of the stock on the ith day is array of I. It has been given by the array, and find all the days on which you can buy and sell the stock so that in between the profit is maximum. Note that there are various answers possible, right? So if you see this, right, if you see this, the output for this case is 1y, because you can do what? One possible solution is 0, 3. Okay, so at the 0th cell you buy it at 260, okay, and you buy it at 100 and sell it at 260. or you buy it at let's say index 4, or you buy it at 310 and sell it at 535. Okay, this is also one of the opportunities. So if you will observe for this case as well, so there are a lot of circumstances. So for doing this, what you can do is, like, we need to focus more on the problem now. Okay, so in this case, what will you do? So I will say that inside my main function, what I will be doing is, I will simply ask you this thing, that what you will do is, you will write a recursive function. Initially, what you will say is that you will be starting from the index, let's say 0. You will be starting from array of I is equal to 0. Okay. After this part is done, so what would you do? If you start from 0, you will pass the let's say, pass the price array as well. Okay. And you will say that currently you will mark the bot as false. Okay, because you have not bought. And you'll also pass the number of transactions that you have done up till now. Okay, this is what you would do. Clear? Let's discuss this. So for this, what I would be doing is, let's say if I start, okay, if I start, so what are the circumstances? If I'm inside a function, so when can I return? So int, let's say I have a recursive function in which I have the price array that I have already given, then I have the index I, and I have bool uh, bot is equal to true or false. Okay, if you're currently buying or not, like, let's say if I name it as buy only. Okay, so in this case, what are the circumstances? See, if I is equal to n, then you will say that, okay, there is going to be no profit, and I will simply return 0. Okay, basic recursion. Apart from this, what you would do is, you will check that, suppose that if the buy is equal to false, in that case, what will you do? Anyone will tell me if the buy is equal to false. So that means currently I have not bought any stock. So what would you do? If you have not bought any stock, then there can be two choices in front of you. The choice one can be that what you do is, you pass the recursive function, you pass the prime, you pass the next, you go to the next index. Okay, and you don't buy this particular stock. Okay, so you don't buy. This is when you don't buy. Okay, this is when you don't buy. Or other choice that you could have is, the choice number 2 that you could have is, you call the recursive function, you pass the prime, sorry, price, not prime, but basically price. Okay, and then you move to the I plus 1th, and if you are buying it, so you mark the buy as true. So what you will do is, in this you will pass true because you have bought it. Okay, now what you will do is, after this plus, no, if you are buying it, so that means your profit is decreasing, like your amount with you is decreasing, so that is nothing but minus of r. Okay, that is what you would do. Okay, this is what we would do naturally. Now apart from this, suppose else, in the else part, if it is already bought, right, if the buy is equal to true, if it is bought, so you will try to do what? You will try to sell it or not sell it. So the choice one is, let's say I give you the choice one, that you don't sell it. If you don't sell it, you call the recursive function, you pass what? You pass the price array, you go to the next I plus 1, and you keep the bought as true only. Okay, otherwise, what is the second choice that you can have? The second choice that you can have is, you can have the recursive function, you can pass the price. Okay, you can pass the price. Okay, you can have what? You can have the index I plus 1. Okay, you can mark it as false, because if you sell it, then next time you will be eligible to buy it, to buy a stock. Okay, so you book a profit of array of I, like this. Okay, suppose that in this function transaction was also passed. Okay, suppose in this particular functions the transaction was also passed. So can I say that if I have done one buying and selling, because if my buy was true, then that means I must have bought already. And if my buy becomes if I buy it, if I basically have bought it and I sell it at a plus at a price of RFI, in that case one transaction would be complete. So I can say that transaction minus one also I can pass. Suppose if I was passing the transaction as well. But how can we see that there will be overlapping problems? So basically, what will the concept is? The concept is that you can observe this particular I, this is always changing, right? This I and buying is changing. So in this also, you can have what? You can have a 2D table. Okay, you can have a 2D grid, or you can have a 2D DP, which can store what? Like this DP can store the index and the buying status, right? The buy status, whether you have bought it or not. By doing this, what you will be doing is, you will be able to check that if you are calculating some values again and again or not. Because if you have this recursive call, right, if you have a lot of recursive calls, and suppose there is a recursive call like for a particular value of I and j, and in the right subtree as well, this recursive call represents the for the common part, right? For the same values of I in the value of j. In that case, if this is already calculated here, so you'll not calculate it again and you'll directly return it. Understood this part? Yes or no? Please write a yes in the chat. I hope that everyone has understood this part. Correct? Clear with this part, everyone? Okay, everyone is clear with this part? So this is what in general memoization means. There can be many problems, like you can have word wrap problem as well. You can have a problem like word wrap, you can solve it using this approach. There is another problems that is ones and zeros. Okay, there are a lot of problems that can be made on this particular concept, but I hope that you were able to get this thing. So this is something that I have taught. Now I would like to take some questions from the chat. So if anyone has got any questions, they can tell me. I can take the questions for you now and clear your doubts. If you have any doubts related to competitive programming, or you have any doubts related to GFG or any of its courses or anything, so you can tell me. I can take those doubts. Anyone? Anyone is having those kind of doubts, they can tell me. You have any doubts, you can write your things in the chat. I'll be more than happy to answer them. Anyone has got any sort of doubt? Anyone wants to ask anything? Okay, Hitansh is saying no doubt. What about other people? Okay, you want to ask something? Okay, okay, perfect. Great. So if no one has got any doubt, that's great. Fine with this. Okay, guys. So I think that it was it. That was it, because you do not have any doubt. So the organizers, if you find any doubt, you can send it to me. Otherwise, no problem with that. Okay. So I think that no one is having any doubt. If you have any doubts, you can ask me. I'll answer it right now in the chat, like related to CP or related to any other thing. For those who are in their first year, or anything. Okay. So I think no doubt is there. Perfect. 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 So thanks a lot for having me for this particular session, guys. I hope that you enjoyed a lot, although it was a like normal session. So we tried to cover the concept of DP and why it is used. I tried to cover the memoization part of it. I told you about some variations like knapsack. You can also do it in best time to buy and sell stocks. Stone games can also be a problem. Word wrap, as I've already told you, ones and zeros. So there are a lot of problems where you can apply this particular concept, that if a particular state is already calculated, it can be 3D as well. It depends on the number of variables that are changing in your recursive function. Okay, so this was it. Thank you for having me, everyone. I am glad that I had this session in your college. Yes, Arman, you can take over from here.
Thank you so much, sir,
Uh,
enlightening us with your knowledge and experience. It's a pleasure for all of us to be taught by you, sir. Thank you, sir, for giving your valuable time and sharing knowledge with us. Special thanks to GFG and Coding Minutes for being our title sponsor and education partner. Now it's time for you guys. The link of quiz is there in description right now. Check it out. Winners will get exciting prizes. So what are you waiting for? Hurry up, grab the prizes, and once again, thank you everyone joining today's session. Bye.
So you think you know data structures well, but often get stuck when it comes to problem solving. Well, now you are at the right place. Welcome to Data Structures and Algorithms Level Up course. Hi, my name is Prateek and I'm a software engineer at Google. I have created this course for anyone who wants to learn how to apply data structures for solving coding problems and algorithmic optimization. In the past 5 years, I have taught over thousands of developers through my online and in person bootcamps that helped many students and working professionals in their careers immensely. This course will help you to develop a strong problem solving mindset and write cleaner and highly optimized code. This course is a highly practical course, and we will discuss over 100 problems of varying difficulty levels along with a complete hands on implementation. You will learn various tips and tricks related to concepts like recursion, backtracking, sliding window, two-pointer problems, dynamic programming, pattern matching, graph algorithms, and more. Not just that, you will also learn by solving problems involving various data structures such as stacks, queues, linked lists, heaps, hash tables, tries, and graphs. With over 200 plus high quality video lectures, concise and simplified explanations for complex topics, this course is your one stop destination to master problem solving. Unlike most other courses, this course is fully interactive. You also get coding exercises and multiple choice questions to test your skills. The code judge ensures that your logic is correct and you get a real time feedback on your code submission. Doesn't matter whether you have a computer science background or not. This course is for anyone who wants to ace problem solving and achieve big. So what are you waiting for? Sign up today and I'm looking forward to meet you in the course.